Hey developers, welcome to Coding Smarter, Not Harder. We're kicking off our deep dive into AI agents, and trust me, this is way beyond your IDE's autocomplete. Think of an AI agent as that brilliant but sometimes naive junior developer you pair with. They're autonomous, goal-oriented, and can interact with tools. But critically, they need your precise guidance. They're designed to tackle complex tasks by breaking them down, not just guessing the next line of code. So how do these agents actually think? At their core, they leverage powerful large language models, LLMs, as their brain. But crucially, LLMs alone aren't enough. These agents are also equipped with tooling, programmatic interfaces to interact with systems, databases, and even your existing APIs. The LLM acts as the cognitive core, reasoning and making decisions, while the tools are its hands, executing those decisions. It's how they maintain context across multiple steps, keeping track of their progress. This brings us to the agentic loop, their fundamental workflow. It's a continuous cycle. They first plan a series of steps to achieve a goal, then execute those steps using their tools. After execution, they observe the results, and then reflect on what happened, adjusting their plan if necessary. This iterative problem-solving allows them to self-correct and incrementally work towards complex outcomes, much like a human developer debugging an issue. You might be thinking, okay, but how does this apply to my cloud-native stack? In real systems, this shows up when an agent can, for example, generate a complete Kubernetes deployment YAML from a high-level service description, or even scaffold an entire microservice with database and API definitions. They excel at automating boilerplate code, generating infrastructure as code, and configuring complex cloud resources, tasks that are tedious but essential for rapid cloud-native deployment. This capability profoundly enhances our developer workflows. By offloading repetitive, well-defined tasks to AI agents, we reduce cognitive load, freeing us to focus on higher value, more creative problem-solving. Imagine rapid prototyping where the agent handles much of the initial setup, or using them to assist in code reviews and refactoring by suggesting improvements. Rather than writing the entire solution from scratch, it's about augmentation, not replacement. To make this happen, agents integrate into our existing environment through various touchpoints. They can interact via APIs, SDKs, or even as IDE extensions, living right within your editor. Critically, they can be embedded into CI/CD pipelines, automating tests or deployment configurations, and leveraging cloud provider APIs directly to manage resources. The key is their ability to programmatically interact across your entire cloud-native toolchain. Ultimately, AI coding agents offer a strategic edge for agility and standardization. They promise faster feature delivery, reduced onboarding time by codifying best practices, and a more consistent codebase by enforcing architectural patterns. Understanding their technical backbone is the first step to leveraging them effectively. But what are their actual practical limits, and what can't they do right now? That's what we'll dive into next. In our last scene, we defined AI coding agents. Now let's peel back the layers and truly understand what they can deliver, and crucially, where their current limits lie. Think of it like this. Your brilliant junior developer, fresh out of an intense bootcamp, is incredibly fast at routine tasks. AI agents excel at rapid prototyping and boilerplate generation. They can churn out basic function scaffolds, API endpoint definitions, or routine UI components in mere seconds. This isn't just autocompletion. It's generating significant chunks of functional code. What once took hours, or even days of repetitive setup, can now be reduced to minutes, accelerating your initial development velocity immensely. Beyond starting from scratch, these agents are also surprisingly adept at streamlining existing codebases. They can identify redundant code, suggest minor optimizations, and even refactor small, well-defined modules with impressive speed. This isn't about deep architectural changes, but rather the incremental cleanup that often gets deprioritized in a fast-paced environment. It helps prevent some of that spaghetti slop code we've all encountered, especially when applied to localized issues and smaller contexts. And it's not just functional code. AI agents can significantly enhance quality and maintainability. They're good at generating unit test stubs, sketching out basic integration test scaffolding, and even drafting initial documentation. Imagine getting a head start on those crucial, but often delayed, tasks like creating API reference docs or basic RE-ADMEs. This can truly free up your time for the more complex, creative problem solving that truly requires human intellect and nuanced experience. Now here's where the analogy with our junior developer really shines, and where those Reddit concerns come into play. You might be thinking, this sounds amazing, why aren't we fully automating everything? Well, the junior developer, while brilliant, often loses focus when faced with a huge, unfamiliar codebase. In real systems, this shows up when an AI agent, given a large, complex project, struggles with context and consistency. It might generate code that's technically correct in isolation, but fails to integrate properly with existing architectural patterns or complex dependencies. This often leads to inconsistent coding styles, or, worse, subtly incorrect implementations that only surface during runtime in production. This struggle with context makes them particularly ineffective for critical bug fixing or deep debugging. When you're wrestling with an obscure race condition or a memory leak in a distributed system, an AI agent will often provide superficial suggestions or, frustratingly, get stuck in feedback loops, reiterating the same incorrect advice. It lacks the deep, nuanced understanding of a system's internal state, its historical evolution, or the subtle interactions between its components. This is precisely why relying on them as a crutch can hinder fundamental problem-solving skills for new programmers. And let's be blunt, AI agents are not innovators. While they can generate code, their output often feels like pseudocode, syntactically plausible but conceptually shallow, especially for novel solutions or truly optimized algorithms. They operate by pattern matching, not genuine comprehension. They won't design an elegant new architectural pattern for your cloud-native system, or identify a paradigm-shifting approach to a long-standing performance bottleneck. That still requires human intuition, creativity, and years of accumulated wisdom, not just a prompt. So AI agents are powerful tools, but they are not replacements for human developers. They are accelerators for routine tasks, enabling you to move faster. But for critical work, they still require constant guidance, rigorous code review, and your expert human judgment. They augment your capabilities. They don't automate your expertise. Understanding this balance is key to leveraging their value without compromising code quality or your own growth as a developer. Next, we're going to dive deep into a direct comparison of code quality and efficiency. AI-assisted versus manual coding. We've explored what AI agents can do and where their current limits lie. But the real question for any developer, especially in cloud native, is how does this actually impact my code's quality and efficiency? It's a critical comparison because nobody wants to trade velocity for mountains of technical debt. When AI agents generate code, they often get the syntax right, sometimes even an entire function or class structure. It's like having that brilliant junior developer who can quickly scaffold a new service or write boilerplate API endpoints. The initial correctness looks high, but dig a little deeper, and you might find subtle logical flaws, edge cases missed, or assumptions baked in that don't align with your broader system architecture. It compiles, it runs. But is it correct for robust production use? That's a different beast entirely. This brings us to maintainability, and frankly, the specter of spaghetti code. Reddit developers frequently point out how I can generate code that's overly verbose, lacks proper abstraction, or just isn't elegant. It's functional, but convoluted, making future debugging or enhancements a nightmare. This is exactly where our brilliant but sometimes naive junior developer analogy shines. They're fast. They get the job done, but without constant guidance and rigorous code review, their solutions might be overly complex, lacking the nuanced patterns and best practices that come with years of experience. I've seen teams adopt AI for quick wins, only to find themselves drowning in functions that are 300 lines long, duplicated logic, and brittle dependencies because the agent prioritized getting it done over getting it done well. The cost of refactoring can quickly outweigh any initial velocity gains. Then there's performance and security. An AI agent, unless specifically prompted and meticulously fine-tuned, isn't inherently optimizing for low-latency cloud environments or adherence to strict security protocols. It won't automatically use the most efficient data structure for a massive dataset, or implement advanced encryption best practices without explicit instruction and subsequent human validation. Human developers, with their deep understanding of system constraints, data volumes, and threat models, are crucial here. They review, optimize, and fortify. Without this human layer, you could be deploying code that, while functional, introduces significant performance bottlenecks or critical security vulnerabilities into your cloud-native applications. So the question isn't whether AI can write code, but whether it writes good code. And if not, how do we integrate it effectively to get the best of both worlds? Next, we'll explore exactly how to integrate these agents into your development environment. After weighing the quality of AI-assisted code, the next logical step is figuring out how to actually put these AI agents to work. How do you integrate them into your daily grind, your muscle memory? It's not just about a standalone tool. It's about embedding them where they can genuinely accelerate your workflow, much like that brilliant junior developer we discussed earlier. First up, let's talk about integrating directly into your integrated development environment, or IDE. This is where most of your actual coding happens. Plugins for VS Code, JetBrains, or your editor of choice allow AI agents to offer real-time autocompletion, generate boilerplate code, suggest refactors, or even catch simple errors as you type. It's like having that brilliant, eager, but sometimes naive junior developer sitting right next to you, constantly offering suggestions. They can churn out routine code snippets at lightning speed, freeing you up for more complex logic. But remember, rigorous code review of their suggestions is absolutely non-negotiable. Moving beyond local development, AI agents can be powerful allies in your CI/CD pipelines. You might be thinking, will this just create more spaghetti code in my pipeline? Not if done right. Think pre-commit hooks that use AI to lint, reformat, or even generate initial unit tests before human review. Code review bots can flag potential issues, suggest improvements, or check for adherence to coding standards. I've seen teams leverage this by integrating agents that automatically generate detailed test cases for new features, then run those tests and report coverage, significantly reducing manual effort. This isn't about replacing human QA, but about offloading repetitive checks, allowing your human engineers to focus on edge cases and complex validation. Finally, the more holistic approach. Integrating AI agents into your broader cloud-native toolchain. This means leveraging them for tasks like infrastructure as code generation, optimizing deployment manifests for Kubernetes, or even helping design observability hooks across microservices. You can integrate via APIs for custom solutions or use native cloud provider services. The key here is not just generation, but intelligent assistance that understands the context of your entire distributed system. It's about using AI to inform architecture and deployment, rather than just writing a function. This opens up a world of possibilities for truly smarter, more efficient development. But how do we customize these agents for our specific domain needs? We'll explore that next. Alright, you've integrated your AI agent, handling basic boilerplate. But what happens when you push it beyond simple autocompletion? You might be thinking, can these digital assistants truly tackle a seasoned developer's most complex tasks? We're talking refactoring, generating robust test cases, and customizing agents for specific, domain-driven patterns. We'll compare their effectiveness in these higher-stakes scenarios, seeing where they shine and where your critical human eye remains irreplaceable. Consider refactoring. An AI agent can spot code smells and suggest minor restructurings. But for major architectural shifts or optimizing complex algorithms, suggestions often demand significant human guidance. Similarly, for test cases, agents rapidly generate unit tests. Yet, quality is crucial. I've seen teams get high coverage numbers, only to find tests brittle or missing critical business logic. It's like that brilliant junior developer. Fast code, but you still rigorously review crucial PRs for true quality, not just quantity. Now imagine customizing agents for domain-driven design. DDD deeply aligns software with business realities, using ubiquitous language and bounded contexts. Can an AI agent truly grasp your specific domain's unique aggregates or value objects to propose your architectural patterns? Out-of-box agents struggle. They know general patterns, but lack deep contextual understanding. To make them genuinely useful, you must train them extensively on your codebase and design documents, teaching them your unique dialect. This isn't trivial, it's significant engineering. This leads to custom agent development, fine-tuning an agent on your proprietary framework or legacy monolith for cloud-native modernization. The potential for tailored assistance is huge, but it's a significant investment. Curating high-quality training data, managing pipelines, and rigorously evaluating output against specific constraints. It's not plug-and-play. Comparing effectiveness, AI excels at mechanical aspects, providing velocity, but for deep contextual understanding, creative problem solving, or adherence to implicit architectural principles, human oversight remains absolutely critical. Ultimately, leveraging AI for these advanced tasks requires understanding its strengths and, crucially, its limitations. You need a discerning eye for its output, knowing when to accept, when to refine, and when to completely rethink. The question isn't whether AI can do something, but whether it should, and under what conditions. Next, we'll dive into a technical comparison matrix, evaluating specific AI agent features, performance benchmarks, and the real-world costs and trade-offs you need to consider for informed decisions. Alright, we've explored AI agents. Now let's compare leading tools. It's about real-world impact on your coding, velocity, and budget. Finding the right brilliant junior developer for your needs is key. Like junior devs, agents vary in code quality. Some prioritize speed for simple tasks. Others offer deeper, multi-file context. Context retention is critical. How well an agent recalls your project's architecture, impacting suggestions for cloud-native patterns. Raw performance, latency, and throughput impact your dev flow. You might be thinking, is a few seconds a big deal? Micropauses break focus. Low-latency agents maintain flow during rapid iteration, crucial for high-velocity cloud-native development. Seamless integration is non-negotiable. Does an agent augment your IDE/CI/CD or force disruptive changes? I've seen teams struggle with new workflows. The best fit integrates invisibly, enhancing current setups. Look for native plugins and robust ecosystem compatibility. Here's the spaghetti slop code concern. Fast agents generate overcomplicated or incorrect code, increasing review load, necessitating rigorous code review. Advanced agents aim for cleaner output, but often cost more. Balancing speed with diligent human oversight is vital for high code standards. Costs aren't just subscriptions, they include valuable review time. Pricing varies per token, monthly, enterprise deals. True ROI balances generation speed, code quality, and human correction. A cheaper agent isn't a bargain if it doubles debug/refactor cycles. Assess total cost of ownership. Finally, specialization. Can an agent learn your domain-specific language or internal frameworks? Basic agents often fail, getting stuck in feedback loops on unique codebases. Customizable agents, fine-tuned on private repos, offer superior relevance/quality for complex cloud-native architectures, becoming a tailored partner. Understanding these trade-offs is paramount. Next, we'll dive into best practices for maximizing AI agent value and minimizing pitfalls. After comparing various AI agents, the critical question becomes, how do we effectively work with them? It's like pairing with that brilliant, but sometimes naive, junior developer we talked about. They can accelerate routine tasks incredibly, but they require constant, clear guidance and rigorous code review for anything critical. Our goal is to leverage their speed without sacrificing quality or our own learning. First, we need to master prompt engineering. Think of it as providing crystal clear specs to our AI junior. You might be thinking, I already prompt, but it goes beyond just asking for code. It's about structuring your requests, defining constraints, specifying desired patterns, and even providing examples. A vague prompt often leads to over-engineered or contextually irrelevant solutions. That's spaghetti slop code we want to avoid. This leads directly to the art of iterative prompting. Don't expect perfection on the first try. Treat your interaction with the AI as a dialogue, a feedback loop. If the initial output is too verbose, refine your prompt. Make this more concise, focusing on core logic. If it's missing error handling, add robust error handling, specifically for database connection failures. It's a continuous dance of asking, observing, and refining. Next, and this cannot be overstated, rigorous code review is your human firewall. I've seen teams, blinded by initial velocity, push AI-generated code directly to production without proper scrutiny. This is where you risk introducing subtle bugs, security vulnerabilities, or simply overcomplicated, unmaintainable patterns. Every line of AI-generated code should be reviewed with the same, or even greater, skepticism as junior written code. You are the ultimate gatekeeper. Crucially, we must guard against over-reliance, avoiding the crutch. AI agents are phenomenal tools, but they should augment, not replace, fundamental learning and problem-solving. If you find yourself blindly accepting AI suggestions without understanding the underlying logic, you're hindering your growth. Use AI to explore solutions, generate boilerplate, or catch edge cases, but always strive to understand why it works, or doesn't. To maintain high code standards, integrate AI into your existing quality gates. This means static analysis, unit tests, and integration tests must run on AI-generated code just as they would on human-written code. Train your AI to generate code that adheres to your linter rules, your architectural patterns, and your team's coding conventions. Provide it with your internal style guides and component libraries. Finally, consider test-driven AI development. Instead of just asking for a function, ask the AI to generate the unit tests first based on your requirements, and then generate the code to pass those tests. This forces the AI to think about edge cases and expected behavior, often leading to more robust initial implementations. It shifts the paradigm from just code generation to a more complete, quality-focused process. Understanding these strategies helps us master working with AI. But what happens when the code is already deployed and things inevitably go wrong? How do AI agents assist or even hinder in the complex world of debugging, refactoring, and intricate architectures? So far, we've mostly talked about AI agents accelerating routine coding. But what about the really complex stuff? Debugging that cryptic null pointer exception in a distributed system? Refactoring a decade-old monolith? Or designing a resilient cloud-native architecture from scratch? Where do our AI junior devs truly fit in here? When it comes to debugging, AI agents can be surprisingly helpful for identifying syntax errors, pointing out common anti-patterns, or even suggesting fixes for well-known library issues. They're great at pattern matching across vast code bases, but for deep, non-obvious logical errors, especially those spanning multiple microservices, they often falter, struggling with the holistic context. Refactoring legacy code is another beast. I can automate boilerplate changes, suggest modern idioms, or even outline a strategy for breaking down a large function. Yet, understanding the original intent behind spaghetti code or anticipating downstream impacts across an entire enterprise system requires a human touch. It's more than just syntax. It's business logic and technical debt. I've seen teams try to use AI for initial drafts of cloud-native architectures. Picture a moment where an AI agent churns out a Kubernetes deployment for a new service. It gets the basics right: pods, services, ingress. But it often misses the nuance of existing security policies, specific cost optimization strategies, or how this new service aligns with the long-term strategic roadmap of the entire organization. This is where our brilliant but sometimes naive junior developer analogy hits hard. They can generate code quickly, but the critical guidance for complex, strategic work is entirely on us. This leads us directly to AI's current constraints in these advanced scenarios. They still struggle significantly with long context windows, often losing focus on larger code bases. You might be thinking, how can it generate good code if it can't even remember the entire project structure? Exactly. They can also get stuck in feedback loops, producing pseudocode, or even confidently hallucinating solutions that simply won't work in a real-world, cloud-native environment. Comparing their utility to human expertise, AI agents are powerful assistants for the initial heavy lifting or for exploring generic solutions. They can be a fantastic brainstorming partner, rapidly generating options. However, for critical thinking, deep problem-solving, understanding intricate domain knowledge, and making strategic architectural trade-offs, human developers remain indispensable. Our experience provides the crucial filter. So whether it's a tricky bug, a massive refactor, or designing the backbone of your next big cloud application, consider the AI agent your highly capable but still very junior pairing partner. Their output always requires your rigorous code review and understanding. This balance is key to leveraging them effectively without compromising code quality or your own critical development skills. What happens when this evolving partnership matures? Let's explore the future of your role as a cloud-native developer. As we've explored the capabilities and current limits of AI coding agents, it's clear we're not just getting new tools. We're witnessing a fundamental shift in our role as developers. Gone are the days where writing every line of boilerplate code defined our value. Instead, we're transitioning from code generators to code orchestrators. Think of it like this. Your AI agent is that brilliant but sometimes naive junior developer we talked about. They can accelerate routine tasks, crank out basic functions, even suggest elegant solutions. But they absolutely require your constant guidance, your architectural wisdom, and rigorous code review for anything critical. If you're not careful, they can produce what some might call spaghetti slop code, if left unchecked. You might be thinking, so what are my responsibilities now? Well, it's about elevating your game. I've seen teams where developers who embraced prompt engineering, understood the nuances of AI output, and focused on high-level system design rather than just coding minutiae, became indispensable. Our focus moves to understanding the why behind the code, rather than just the how. This means our skill development must also evolve. We'll spend more time on prompt engineering, refining AI instructions, and performing critical architectural oversight. Our responsibilities expand into understanding the security implications of AI-generated code, optimizing its performance, and navigating the ethical considerations of AI agents. It's no longer just about writing functional code. It's about curating, validating, and guiding an AI to produce enterprise-grade solutions. The complex debugging and innovative problem-solving still largely fall to us for now. Ultimately, the cloud-native developer of the future isn't replaced by AI, they're augmented by it. Our role becomes one of strategic thinking, system design, and rigorous validation. It's an exciting, challenging evolution, requiring us to embrace continuous learning. Thank you for joining me on this deep dive into AI agents. If this video sparked new ideas or challenged your perspective, please hit the like button. Let me know in the comments. What's one skill you believe will be absolutely critical for developers in this AI-augmented future? Don't forget to subscribe and ring that notification bell so you don't miss our next insights. And for a deeper dive and all the resources, check out the full playbook, link in the description below.